Hello, Munich. It's my first time here, and I'm really excited to talk to all of you. So I'm Keerthana Krishnan. I'm coming all the way from India, and I'd like to talk to you about my experience with handling the front end and web architecture. So about today, what happens is that our product was created 8 years ago. And then a few years later, in about 2017, our team found out new motors have come into the marketplace after we started our product. So our customers are demanding, you need to add this additional feature. You need to add this entire new set of features. And we decided that in our current monolith framework, it's not possible to add them anymore. So necessity pushed us, and we had to find creative ways to add these features. So we experimented with web architectures, and I'm here to tell you about the results for that, the pros and cons, and some great use cases that we found from trial and error so that you don't have to go through them. Let the cage match between the architectures begin. Consider a use case. Now, as you can see, this is not oil software, this is Amazon. You might be confused for a minute by all this stuff happening, but it's still Amazon. So due to an NDA, I cannot show you my code. I cannot even think of my code right now. So let's find something almost as complex, if not more complex. Trust me, we are more complex. Amazon. So this UI, I hope nobody works for Amazon here, because I'm going to call it ugly. It has a drop-down over there, a list of recommendation, ads on top, ads on the side, a search bar, another drop-down, user details. So many things happening in this one small UI. You would not call it clean. The screen is full of data, because when we ask them, do you want us to give you a beautiful minimalist UI with React? They're like, what is this React? No, show me all the data. I want to monitor oil, right? So that's the kind of use case I deal with. So what was it? What did my application look like? So all monoliths in general, now we're using Amazon here, Amazon, they have logical units structured inside them. So when your code starts out its life, nobody starts out as a microservice. It starts out as one single unit. So in Amazon's case, it probably has items it needs to sell, its users, the users rating their items, vendors, ads, all that thing is bundled into one single unit, right? That's a monolith. Now, in the future, when Amazon divided it up, how did their microservices probably look like? Let's venture a guess. So items probably are their own logical unit. Users probably have their own logical unit. All those logical components which interact independently from each other probably got a microservice of its own. So this is just to help you visualize how an ideal web architecture is going to look like. What happens when we turn this down into a serverless architecture? In serverless, we further subdivide it. So if you think of the user as a logical component on its own, in serverless, adding a user, simply that functionality is by itself one function. So you add that to the serverless server, which Amazon hosts in a secret undefined location, and you just put a function call to that. So all of your entire logic is subdivided into these simple, pure functions, which you can call, and it just runs somewhere. So that's how serverless is. In the beginning, and I got a pro tip from one of the speakers yesterday, add a cat pic, free laughs from the audience. So that's your cat pic. So in the beginning, your code base is small, it's cute, you remember the file names, you can think of the edge cases, like when I add this, divide by 0 will happen. Yeah, that's probably the only edge case. You can think of it. It's small, it's cuddly. What happens? You add another feature, you add another feature. Something breaks in production and you put a band-aid somewhere. Something else breaks and then it's held together by prayers. A few more features, a few more years later. This is what happens when you try. That's what that cat becomes when you try to change anything in production. Trust me, this has happened to us, not the tiger, but still. Tiger would have been better, trust me. So, in our real life scenario, our application has been running for 8+ years. Now, this is a product that generates a multi-million-dollar revenue, right? We can't just simply change one part of it. Our company would fire all of us. It's written with JavaScript and Java. After 8 years, Let me tell you, most of the people who wrote some of the original functionality are no longer with us. I can feel somebody like, oh God, the pain you feel. So this is our team last year. That's Alice falling into the rabbit hole, for those who got it. And we decided, nope, our customers want this functionality. By hook or by crook, we are going to get this done. I would not recommend that you break up a monolith. From hindsight, my team lead would not recommend that you break up a monolith. If we had thought of it clearly, well enough, he would have thought, if we needed to add the new features, we would have just taken 3 months more and built another application. That would have been easier. That would have been better. But no, we took the first step. We were enchanted by the rabbit. We looked at the rabbit hole and we thought, it's just only 1 feet. We can do this. We could not do this. So what did we do? We are not crazy people. We did not one day decide to break up a monolith. We are smart people who decided to do a proof of concept. One small proof of concept for a microservice and another one for serverless. And as proof of concepts go, they worked out pretty well because they're small. Small kitten again. I deliver. So when the small POC works, what's the next step? The proof of concept worked, so this has to work. So we report to our product owner. So we told him, yeah, the proof of concept worked. So he took out his calculator, like, we have 40 engineers, we have 10,000 files. Yeah, we can do this in 4 months. We can convert the entire monolith into a bunch of serverless functions. 4 months, it's all it should take. Our tech lead, he was a bit more careful. He said, give us 6 months. 6 months, done. Make it your entire code base serverless. It took way more than 6 months. In fact, it's still happening. And initially, when I applied for the CFP, this 6 months, it was still happening. It was in the honeymoon months. So I thought, we'll convert all of that into serverless. I'll give you my honest-to-God feedback about how serverless is amazing, and we now have an amazing application. But to be honest with you, the truth is, a lot of things broke, and serverless is not always the silver bullet function that you think it is. So there are still parts of our monolith left. And that pipeline was built about 1 year into our application, and every single person who wrote that application or that part of our code left. And that is not something we were able to change. So our code looks like this. That is the pipeline that we cannot touch. As we create a newer microservice, it just takes a bit of the blood out of our application, like a bunch of vampire bat microservices exist, but the more blood we take out of this, that Frankenstein monster still lives, we cannot kill it. Steak does not kill it. Sunrays do not kill it. That Frankenstein does not die. That's our monolith. So microservices best practices. So we found out, no, serverless is out of the question, and I'll tell you why later. But microservices, if you have to build them, start fresh, right? If you have an existing application that you want to break, get your knowledge from it, see how your code is made in that, take a few extra months, I'd say, start building the code ground up, and add more microservices as you begin. I'm not saying that it's difficult to add a microservices to a monolith, but the overall code complexity and the way in which you have to figure out so many things, and the rule of thumb is the more years your software has been in production, the more your complexity is higher, and the more it'll be difficult to break up your monolith, right? So from a microservice point of view, you get more control in your implementation. If you have large data-heavy applications like ours is, for example, ours is clearly having a lot of data coming in, real-time data coming in. For those kind of applications, microservices are definitely better. It helps you handle all those large, complex problems that you can't solve in a single function. It gives you control and security. I'll come to security in a minute, and you can customize your microservice. Going back to our use case of Amazon for a second again, because I can't use my business logic to illustrate this point. Imagine a user of Amazon. Now, in the future, now Amazon, you can follow another user, I think. You can follow authors if you follow books. in the future, they might add a few more features for users. Maybe you can follow a vendor to see if they bring up any new products, or you can follow a particular product to see when it's available next. All those functionalities are being done by the user. So if you have a functionality done by a user, a single function of the user, which triggers another function for another component, all those interplay of logic is much better handled when you have a microservice rather than when you have a serverless application. That's something we learned the hard way. So when is serverless a good choice? Good question. It's more efficient for smaller pieces of logic. So again, rule of thumb, the more beautiful your UI is, the more minimalist the UI is, serverless is better suited for you. So if you're starting an application tomorrow, hey, I want to create an application. I'm going to see what are the best places to eat in and around Munich, right? That code base should not be so hard to manage. That should be a very small code base. Or depending on the features that you add to it, it's a user-facing functionality. Things like those, serverless will work pretty well. But tomorrow, if you're going to start writing your own oil and gas monitoring application, your own vendor marketplace, your own application that takes so much of data and then processes it, then serverless might not be your first choice. It would not be my recommended choice. But serverless is scalable. It's easy to change the function to fit requirements. Show of hands, how many people over here, the second last day of your sprint, your tech lead has come to you and said, the client wants one small change in that UI you've built today. One small change. Show of hands. A lot of people have been hit by that arrow in the chest, I see that. So those kind of problems, serverless is a good antidote, right? You can change it very easily, and you can see your changes very easily. Serverless is at work there. And for UI-intensive applications, for applications that use UI a lot, for example, if you use internationalization, localization, progressive web apps, for example, that's a good use case for serverless applications because it's UI-intensive. But data-intensive applications I would not recommend serverless. Maybe in a few years, serverless will become much better adapted to handle larger amounts of data. Maybe we'll figure it out a way. But in the current implementation, serverless is not something I would recommend. Again, no to serverless is UI is crowded? Nope. Data and computation heavy scenarios? No. And data security is something I talked about earlier. So in our application, we have a small problem that you probably will never face. We handle a lot of data which is not us. Oil and gas data is very sensitive. So the manager from Saudi Arabia definitely says things like, I'll give you one server. It will be in Riyadh. You can send 3 engineers to set it up. No data goes out of the walls of Saudi Arabia. Serverless will not work for that. I'm very sorry. You have no idea where your server for serverless is hosted. So for all those applications where your data should be controlled, sensitivity of data, security of data, sure, Amazon has some agreements that you can sign, but can you really trust them? I'm not hitting on Amazon here. I mean, I like it. I use your products. Please don't blacklist me. But still, and the same is the case for Microsoft as well. I'm not competing with just Amazon. All of the serverless providers. This is a valid criticism. And like I said earlier, the function-to-function calls are again pretty brutal. So, calling serverless functions inside microservices. I'm sure a few of you have thought this right now. If microservices can handle complex stuff and serverless can handle function calls, how about I wrap all the complex stuff of one logical unit inside a microservice and I call a serverless inside that? Genius. Right? Right? No. Don't do that. So what happens, and I speak this because we actually tried doing this. I'm not proud to admit that, but we actually did do this. And what happens is that all the negative points of microservices, all the negative points of serverless just come together, and you lose your sleep for 1 week before you give up and you decide to go for either one of the architectures. And we went for microservices, but don't combine them. No. And one more thing that you should be very careful of is that when you choose your microservice, make sure your microservice is not a monolith in disguise. That's one point. It's not in the PPT, but I forgot to add that. But it's similar to, it's the same point of mismatching your web architectures, right? So if you're choosing a microservice, make sure that you choose it as a logical unit. Whatever you do, scalability starts at design. Design is where you decide what is your logical unit. For example, Amazon might not have the exact breakup that I mentioned. Maybe users is not a unit at all. It's just ratings, vendors, ads, all that stuff. But whatever you do, make sure that in the early step of your design, you design it in a way that in the future, you think you'll add more features. Even if you're 100% sure, no, my application is perfect. No more features can be added to this pristine beauty. Still write it in a scalable way. Come on, it's a good thing for your future self. And documenting your functions is something else that it's so criminally underrated. Especially as engineers, we do this. We write a function, it works. So I've seen documentation in my own company code where the documentation for a function is // it works. So poignant. So please say what your function name is, have a system to record it. And where this definitely becomes a pinch point is, imagine that you implemented your serverless architecture. All of your functions are now serverless. It's done by a few engineers. 2 years down the line, they have left your company. 2 more new engineers join, and now they have to understand what this hellscape of function calls is. There is no documentation. In that situation, there will either be a riot or 2 more people will quit your company. Either one of those will happen. So document your code. And good quality code. And good quality code, there are a lot of parameters that go into good quality code that I really don't have time to get into. All of us know this. All of us can Google this. So good quality code is definitely an investment for your product's future. In summary, a monolith, unless existing in legacy code and not for commercial applications, it's not recommended. But let's be honest here, every single application starts out as a monolith. Every single thing will start out as a monolith. That's where my previous learnings come into picture. Sorry. When you start out as a monolith, make sure you design it in such a way that in the future you can add more things. In microservices, for example, you can divide and conquer a larger and complex requirement to small individual units. Serverless again, things become much more abstracted. It's best for smaller modular use cases. So that's my time here today. I really loved having all of you, and I'd like to give a huge thanks to the organizers, my wonderful interpreter, and most definitely my team for helping me come here and present to all of you. I'll still be around until the end of this conference, so if anybody has doubts about web architecture, please do come and catch me. And these are some of the references I used, especially Giphy. Big shout out to Giphy. And this is me. You can find me on Twitter as well. Thank you.